Hey guys, so our last unit that we're going to have here is about parent functions and also some generic functions. And this really whole unit here is just a quick review unit that covers the entire year. We like to do this just to kind of sum everything up. And this video, I'm going to try to make it pretty short and go pretty quick because, again, this is review and you can pause, rewind, whatever you need to do for this. So remember, the term parent functions is the most basic form of an equation. And we then can use transformations then to change the shape and location of the parent function of a graph. And we've been doing these transformations all year long, and so again, it should be review. So let's just kind of get started here. I'm going to go pretty quick. The parent functions we're going to be looking at here are going to be starting with linear functions. Remember, linear functions are ones that make a line, and the parent of a linear function is the equation y equals x. And then kind of the basic form that we usually see it in is y equals mx plus b, which again, you remember that m is your slope and b is your y-intercept, and so we don't really use transformations really for this. It's more about just knowing what these mean. And this is the only one in which we do that. Everything else will be dealing with transformations. But y equals mx plus b is your basic form of a linear function. Next, remember we dealt with absolute value functions. Absolute value functions are in remember the shape of the absolute value function is that V shape. And the parent is y equals the absolute value of x. And then if you remember the transformations involved with it, and this kind of looks the same for every single one of these, is it has the y equals a times x minus h plus k, where a, that is your stretch or your compression, and if a is negative, it is a reflection. And then h is a translation left or right. And k is a translation up or down. And it's going to be the same for every single one of these that we're going to go with here. And again, you've seen these before, so I'm going really quick, really fast. So that's a absolute value function. The next one that we dealt with this year is a quadratic function. Notice the shape of this is not a V shape, it's a curve shape. Okay, it's a parabola over there. And again, our parent function here is y equals x squared, because it's a quadratic, so it's x squared. And the form with the transformations is y equals a times x minus h squared plus k. A is, of course, your stretch or compression or your reflection. H is your shift left or right. K is up or down. The next one is a cubic. Again, we dealt with these earlier this year. This would have been in chapter 5. Cubic is y equals x to the third power. Notice the shape of a cubic. It goes down on the left. It goes up on the right. And it goes through 0, 0. And then our transformations, again, of course, are A is your stretch or compression, H is left or right, K is up or down, and then we can shift that value anywhere we need to. All right, the next one, this would have been in chapter 6, already getting into the second semester now. Y equals the square root of x. Remember, this y equals square root of x has a starting point at 0, 0, and then it goes off in one direction to the right. And has the coordinates 1, 1, and then it could have the coordinates 4, 2, and then it could be 9, 3, and so on. And again, the h and k values will shift your values left and right or up and down, and then the a value will stretch, reflect, or compress it. Our next one is a cube root. Okay, this was also in chapter 6. The cube root function, again, is it's the cubic function turned on its side, and it goes to the left and to the left and down on the left side, and up and right on the right side. It goes on forever in both directions and curves through 0, 0. And again, our a value shifts it up, or shifts it, or stretches it or compresses it and reflects it. H will shift it left and right. K will shift it up and down. Next, getting into chapter 7, we had exponential functions where our base was greater than 1. Remember, if our base is greater than 1 in an exponential function, it is exponential growth, and so it has an asymptote at 0. That's the blue dotted line that I have drawn there. That's your asymptote at 0. And then it goes on forever in both directions. Over to the left, it goes on forever approaching 0, but never actually will touch it. It'll always be a little bit above it. And then over to the right side, it quickly grows. And if you remember the coordinates that are on here, this coordinate right here on your parent function will always be the coordinate 0, 1. And then the next point that will always be on here will be this point right here, which is the coordinate 1, and then base, whatever your base happens to be, whatever that b value is. And so those are your points that you can use to draw your curve. We also had exponentials where our base was less than 1, or between 0 and 1, really would be the better way to say it, but it's always going to be positive, but it's going to be between 0 and 1, and so that is exponential decay. And so it flips the graph around the other side. And so as x gets bigger, it approaches 0, it approaches that asymptote. As x gets smaller and becomes negative, it gets bigger and bigger and bigger really quickly. And again, our coordinates here that will always be on this is going to be this point right here, which is 0, 1, and then a point out here somewhere, which would be the coordinate negative 1, and then the inverse of the base. That's a b to the negative 1 power. I didn't really write that very well. Okay, so those are our coordinates on the exponential graph that is a decay. Next, we had logarithms, also chapter 7, everybody's favorite, logarithms. Our asymptote in this case is going to be vertical at 0, and our graph is an exponential turned sideways. And this is where our base is greater than 1. Our points that we will use on our curve are going to be this coordinate right here, which is 1, 0. And this point right here, which will be the point base 1. Okay, remember what a logarithmic graph looks like. And then we have our logarithm graph where our base is less than 1, but still greater than 0. We didn't do a whole lot with these, but we did talk about them briefly. I'm going to go ahead and just kind of show you what the graph of this looks like. Again, it's a vertical asymptote at 0. Our point, again, right here is going to be the coordinate 1, 0. And then this point out here is going to be the coordinate. Our y value is negative 1, and our base is the inverse of that base because it's less than 1, so it is a fraction that's flipped around, and so it's going to be like that. And again, our a value, h value, and k value will still shift we'll stretch it, compress it, and shift it left, right, up, and down. And the same thing is up here, and here, and here. Those h and k values will shift it left, right, up, down. The a value will stretch it. The very last one that we have is rational graphs. Y equals 1 over x is your parent function, but your basic form is a over x minus h plus k. Notice this curve actually has 2 separate curves to it, and I didn't draw the asymptotes in here. I will go ahead and do that. There are 2 asymptotes on this. There is a vertical asymptote and a horizontal asymptote, both at 0. And when you shift this whole thing, you shift it left, right, up, down, based on the h and the k values. The asymptotes also switch or shift around. And then your curves, then you can draw those by making a table and go from there. So again, I know this video is very short. I went very fast. Again, this should all be reviewed. This is stuff we've done all year long. If you need more help or want me to go over some more examples with you, I'm happy to do that if you go ahead and join me on a Zoom session this week or next week. And in the meantime, have a good week, stay safe, and I might talk to you later.